So in this example, we're going to go the other way around. We have a piecewise function that has been given to us, and we have to graph it. The way I'm going to graph it is I'm going to use a method called graph and erase, and you're welcome to follow that method. We have to graph the piecewise function piece by piece. So let's get started with our absolute value function. The absolute value function has a vertex at -4, 1, and the dilation is 1/2. In other words, we go up 1, 2 to the right, up 1, 2 to the right, up 1, 2 to the right. Keep going like that as long as you can, and equally to the left, 2 and 1 up. This would be the graph of our absolute value function if x was unlimited, if the domain was unlimited, but as you know and as you can see, this only counts for the part where x is less than 0, so we have to now go ahead and erase the part where x is 0 or more. See, it can't be equal to 0 either, so we have to erase that bit and indicate this by an open circle. Now let's graph our second part of the piecewise function. This is actually a constant. The function is y is equal to 3. We don't care about what the x value is. All we know and all we care about is that y is going to be the value of 3, and it's going to be a horizontal line going from 0. The domain says 0 is less than or equal to x, so here we are actually going to write a closed circle over the open circle we had before, but where x is 2, we put an open circle because the domain says x is less than 2. For our third part of the function, we're going to use green, and this is a linear function as you have seen them many times. You know these functions very well. -2 is our y-intercept. Our slope is 3/2. In other words, up 3, 2 to the right, up 3, 2 to the right. Keep doing that as long as you can. And backwards, down 3, 2 to the left, down 3, 2 to the left. And again, I'm going to use my graph and erase method. The domain for this part is x is greater than or equal to 2. So anywhere that x is less than 2, we are going to erase. 2 itself is part of the domain. Let me indicate that for you with a closed circle. And here is our graph for the finalized and completed piecewise function. Let's look at the characteristics of this function. First, the domain. For the domain, we start from the left and we keep going towards the right to see which values are actually part of it. As we get to the point 0, we realize that even though the first bit of the function had an open circle, this has been covered and the gap closed by our second piece of the function, by the closed circle. And as we keep going to 2, we see the same happens here. The closed circle in green closes the gap, so we can keep going. And as the arrows indicate to both sides, the domain then therefore goes unbroken from -infinity to +infinity. Or you could also say in set notation, x is an element of the real numbers. Let's look at the range. The lowest value we have for our range is 1, and it's a closed circle, and then both the red and the green arrows go up from there until infinity. In other words, the range is, in brackets, 1 going to positive infinity. End behavior. As x goes to negative infinity towards the left, we're looking now, we see the arrow goes up. That means f of x goes to positive infinity. And towards the right, as x goes to positive infinity, we see that our green arrow also points up, and that means f of x also goes to positive infinity. Do we have any zeros? What are zeros? Ah, yes, x-intercepts, solutions, roots, zeros. There are none. No piece of our graph actually touches or crosses the x-axis. No zeros. Do we have any y-intercepts? We do have one indeed. It's our orange closed circle, and it has the coordinates 0 and 3. All right, let's look at our next example. This is a real-world example. Let's look at it together. A company provides bus tours of historical cities. The given function, c of x, describes the rate for small groups and the discounted rate for larger groups, where x is the number of people in your group. What is the domain and the range for the function? Well, let's look at our domain. The lowest number that is part of the domain is 1. The lowest number of customers that you can take is 1 customer. So the domain starts at 1. And as you can see from the second part of the piecewise function, x is greater than 10. There is no maximum number. There's no maximum number. So the domain goes all the way to positive infinity. Now guys, that must be a pretty big bus, right? If it can take infinitely many people. Obviously that's theory. Also we can take half a person. So technically we don't have all the numbers in between full numbers, but that's something that we're going to discuss at a future point. The domain for our purposes now goes from 1 to positive infinity. And that's the number of customers that we are taking on our bus tours. The range, well, how much money do we make when we take only 1 person? If we take only 1 person, we make $8.95. That's the smallest amount of money that we can make. And equally, the largest goes all the way up to infinity, which is a lot of money if you think about it, right? But I guess if you have a bus that can take infinitely many people, you also need a lot of gas, so you better make a lot of money. Anyway, just kidding. This is it, and I will see you in class.